Welcome to Algebra 2, Semester 2, Unit 11, Section 6.1. This unit is on operations, inverses, and radical equations. I think you guys will really like this unit. This is the first page of the packet. If you turn to the second page, or the one right behind the first page, you will see Section 6.1 right up here at the top. Let me zoom us in just a little. Whoa, not that much. There we go. It says, evaluate nth roots and use rational exponents. If b to the n equals a, then b is the nth root of a. Okay? So let's put this into numbers, because usually with numbers, it makes a little more sense. So what they're basically saying is if 2 to the 5th equals 32, then 2 is the 5th root of 32. Now you might say, well, what does that really mean? What we're doing is we're getting you to where you can convert from 2 to the 5th equals 32 to seeing that the 5th root of 32 is equal to 2. Now if we go back to when I taught you radicals and I said, remember, this is the rule of the prison, and a radical was like a prison fence around factors, then you can really see that 2 is a 5th root because we break 32 down. Let's just do that quickly so that it actually makes sense to you. 32, remember you can break it any way that you want to think of factors for 32. That would be 4 and 8. And then 4 and 8 would break down to 2, 2, 4, and 2. But that 4 breaks down to 2 and 2. So if we circle our primes, we have 1, 2, 3, 4, 5 2's as our prime numbers. So if we put that underneath that prison wall with the rule of 5, remember that's the rule of how many it takes to get one out. We have 5 2's in here. It would take all 5 of these 2's. We would wipe them all 5 out, get them out of prison, but really only one gets out. So that's what the 5th root means. If 2 is the 5th root of 32, it means that there were 5 2's in 32. Now here's the new way that I want you to get comfortable writing this. That means 32 to the 1/5 raised to the 1/5 would equal 2. Okay? So in other words, you could take this and you can convert it over to this being 32 to the 1 and the 5 on the outside. Okay? So if we say 6 to the 3rd equals 216, then we know that 6 is, oops, not and, is the 3rd root, sorry, I have some typos here, 3rd root of 216. And our next step would be to say, well, that means that the cube root of 216, or the 3rd root of 216, equals 6. We can also say 216 raised to the 1/3 is equal to 6. Okay? So now, pause the video and go ahead and fill this one in. 4 to the 5, or 4 to the 5th, equals 1024. Go ahead and pause the video and fill those in. Okay, that would be 4 is the 5th root of 1024. So mathematically we write 5th root of 1024 equals 4, or we can write 1024 raised to the 1/5 equals 4. In other words, 4 times 4 times 4 times 4 times 4 is 1024. Okay, so basically remember that if you've got a fraction here, that you can expand it end up being a to the 1/n raised to the m. And then you can also take that 1 over n and make it into a root and put that inside the parentheses. We're going to practice that just a little bit. So first thing we do is we take this 16 to 3/2 and we write it with 16 to the 1/2 raised to the 3rd. Now we go ahead and write it in radical form with a radical sign in there. So we would go 1/2 means square root, so square root of 16 raised to the 3rd, because that's really mathematically what you end up solving as you solve this. Square root of 16 you should have memorized as 4. 4 cubed is 64. Okay. Next one. We have a negative exponent. Don't forget negative exponents. We need to take care of right away, so immediately we would write that as 1 over 32 raised to the 3/5. Now we can go ahead and take our bottom number inside, so it's 1 over 32 to the 1/5 raised to the 3. Put your top number, your numerator of the exponent on the outside, and take your denominator of that rational exponent and put it on the inside. Okay, now we bring this over and we say that means 1 over the 5th root of 32 cubed. 5th root of 32 we saw up above is 1 over 2 cubed, which means 1/2 times 1/2 times 1/2. I only wrote that out there because I know fractions sometimes, or at least used to, cause you guys to really have to see the problem. So that equals 1/8. Circle our answers over here. Okay, next one. 81 to the 3/4. Pause the video and do this one. It would be 81 to the 1/4. Leave the denominator in there with it. Raised to the 3rd. Now to write that in radical form, that would be 4th root of 81. If you need to break it down to figure that out, please do so. If you broke it down, you would end up with 4 3s. So we know that the 4th root of 81 is 3. Now we raise that to the 3rd. That would equal 27. Okay. Next problem. 12 raised to the 3/8. So we write 12 to the 1/8 raised to 3, which is a radical 8th root of 12 cubed. Now, 8th root of 12, if you go to work that out, you're going to have some struggles and some frustrations because it's not a nice, neat root. When we break 12 down, it's 2 times 2 times 3, so there are not 8 items in there. So when you come to class, get used to doing this and write down the instructions if you need to. What you would do is you turn it on. You'll have a flasher across there, clear your screen. Now you take that 12, you type in 12, then to get to the exponent, go to this little caret symbol, and now you're going to raise it, because it's a fraction of 3/8, because you're going to raise to the 3/8, you need to put it in a parenthesis. 3 divided by 8 and then close the parenthesis. So there's what your screen should look like. 12 raised to the 3/8. You want to include that in parentheses just because some calculators will pick up the 3, but then they'll divide the whole thing by 8. So without the parentheses, it would be 12 raised to the 3rd divided by 8. Okay? With the parentheses, it's actually 12 raised to the 3/8. And now you just hit enter and round that off to, I would say, the second decimal place, the hundredths place. So since it's 0.539, we'd round it to 0.54. So our answer is, and we do need to switch this from being equals, since we're approximating, we do the approximation symbol, about 2.54. Okay? Solving this equation. Well, we do it just like we've done problems in the past. We draw the line down, we work up our PIMDAs, and we know we want to get x alone. Well, at the bottom of PIMDAs is add, subtract. There's nothing being added or subtracted to it. Is there anything being multiplied or divided? Yes. We have a 4, so we divide by 4. We get x to the 5th equals 32. Now, to get rid of a exponent of 5, all we need to do is take a root of 5. What we do to one side, we do to the other. So we have x equals 5th root of 32. Well, the 5th root of 32 happens to be 2, so x equals 2. Because it's an odd root, we are restricted in our sign to be a positive sign. A negative sign will not work, because it would cause the answer to be negative. Okay, on this one, if we draw our line, go up the PIMDAs, everything is locked inside of parentheses way up there at the top, but we can't get inside of the parentheses, deal with it until we deal with the exponents, because we're going up the PIMDAs. So outside the parentheses, there's nothing being added or subtracted or multiplied, divided. First thing we come to is the exponent. To get rid of that exponent, we would take the square, not square root, the 4th root of x minus 3 to the 4th equals, now it'll be the 4th root of 21. Okay? So we go ahead and we wipe out the exponent with the root. We get x minus 3 equals, now with the even root, it's a plus or minus 4th root of 21. Now we add 3 to each side. You can't add inside and outside a prison to get one combined answer unless you were to put that into a calculator, and then it would just be an approximate. I want the exact answer, so we leave it as 3 plus or minus 4th root of 21. Be sure to circle your answer. Okay? Okay, let's turn to the next page, and that's a new lesson. So that concludes Algebra 2-2, Unit 11, Section 6.1. See you in class tomorrow.